All right, good evening. Welcome to our first video homework. Tonight we're talking about slope and direct variation. This is section 2.1. So something that you might hear slope referred to as rate of change. And so when we talk about rate of change, it's saying how fast or what's the rate of what the y value is changing. So in words, we can say for each 1 unit of x, how would help if I could spell how, right? How much does the y value change? Okay, so the answer to that question would be your slope. There's a few different ways that we can kind of calculate or interpret this. The first is with a graph. So I'm just going to graph a random line. Let's do right there. That looks about good. Usually on a graph you want to scale. We'll do 1, 2, 3, 4, 5. So we have a y-intercept of 0, 3. And then 1, 2, I don't want a 1. 1, 2, 3, 4, 5, 6. So we have an x-intercept of 4, 0. Okay. The first thing I can notice after I graph this line is that it's going to have a negative slope. The reason I know that is because you read graphs from left to right, and so as we watch what's happening to this graph, it's going down. So that means that it's going to have a negative slope. For rate of change, what we're going to be looking for is the change in y over the change in x. This triangle is a Greek symbol called delta, and it's math abbreviation for change in. So change in y is essentially our rise, or how much vertically we're changing by, and then the change in x is our run. How much horizontally are we changing? Okay. Based on this graph, we can kind of see what's going on. We're going to be going down. So our rise is a negative number, and then our run typically is always going to be a positive number. So we're following to the right. So you can kind of picture a triangle being built in between two ordered pairs. Okay, our rise in this case goes from a y value of 3 to a y value of 0. So it's going to be going down 3. So the rise is negative 3 units. And then horizontally, our x value starts at 0, and it slides across to an x value of 4. So 4. So our slope in this case is negative 3/4. What that means is for each 1 unit horizontally we're changing, the y value goes down 3/4. And then for each 2 units, it's going to go down 6/4, or 1.5 units. Eventually going over 4 units, that's where we're getting that it's dropping 3 units wide. Okay, we could have used these ordered pairs in our slope formula. You're probably familiar with this, or hopefully you are. So slope can be calculated by the difference in the y values divided by the difference in the x values. We just saw in the last chapter when we were looking at absolute value that subtraction will calculate a distance. So that's exactly what we're doing here, is we're calculating the distance between the y values and then the distance between the x values for the change in y and change in x. Our ordered pairs are 0, 3 and 4, 0. If it's helpful, you can label these x1, y1, and x2, y2. It doesn't really matter which ordered pair is which, but what we're going to do is just substitute in these values. So y2 minus y1 is going to be 0 minus 3, and then we're going to divide by x2 minus x1. So our x2 is 4 minus our y1, or x1 is 0. Okay, 0 minus 3 is negative 3. 4 minus 0 is 4. So notice we're going to be getting the same slope if we use the calculation between the ordered pairs. There's a couple special cases to talk about with lines. And they're the type of lines that have irregular or special slopes. So the first one is the horizontal line. So a horizontal line will always have a slope of 0. And that's because if we pick out two ordered pairs along this line, they're going to have the same y value. Okay. So if we think about that in our slope formula, if y2 and y1 are the same value, 5 minus 5 or 7 minus 7, it's going to end up being 0 in the numerator, so your slope would always be 0. Okay, the other type of special case is with a vertical line. And with this one, the slope is undefined. And we can kind of picture that because if you're picking out two ordered pairs along a vertical line, they have the same x-coordinate. So in our equation, if x2 and x1 are the same, you end up subtracting the same number and you divide by 0, which can't happen. So vertical lines will produce an undefined slope. Okay, we're going to switch gears a little bit, talk about slope still, but look at an application. So with this application, we're going to be answering the question, what does the slope mean in this context? For this problem, Tom works at an aquarium shop on Saturdays. One Saturday when Tom goes to work, he is asked to clean a 175-gallon reef tank, and he needs to drain the tank. And so he starts to measure the water, plots it on a graph, and that's what we have here. Okay, so it ends up taking him 7 total hours to drain the tank, and we know that when he started, the water in gallons that he had was 175. We need to first find what the slope is and then kind of represent what that slope means in words. So we can pick out a couple ordered pairs, or we can kind of use the graph to help us with this triangle representation. For each 1 unit of x, so as x goes from 0 to 1, what's the y value doing? That's going to be our slope. So in this case, it looks like the gallons are going down by 25. So our slope in this case is negative 25. We need to explain what that means. Okay, it really comes from the definition of what slope or rate of change is. That is, for each one x value, the y changes by, and in this case it's negative 25. Okay, so what I did was just take that initial definition of slope that we had for each 1 unit of x. How does the y value change? In this case we know the y value changes by negative 25. So we know what x and y are representing in this problem. So by context we can replace the x and the y with what they're representing. For each one x value, okay, our x value is hours. So it's essentially saying for each 1 hour or for each additional hour. And then the y is representing the water, and more specifically it's the water remaining in the tank, because it looks like we started with 175 and this is calculating how much water is remaining in the tank as time progresses. Okay, so it looks like we're losing 25 gallons every hour. So that would be our slope in context. For each additional hour, we lose approximately 25 gallons of water from the tank. Okay. The units on this slope would be gallons per hour. So when we talk about what that negative 25 means, it's really the gallons per hour that we're losing. Okay, per hour is essentially the same thing as that for each additional x. So it's our rate, negative 25 gallons per hour. Okay, we are going to wrap up our video today with direct variation. And there's different types of variations that we'll talk about throughout the semester. We're starting obviously with direct variation, but there's inverse variation, joint variation, combined variation. Direct variation is the one that we're probably more familiar with, even if you don't know it. It's the one that says there's a proportional relationship between x and y, and by context we have a constant of variation, and we define that to be k. Okay. Our constant of variation means that we have some amount that is varying or changing, but by a constant amount. Okay. This is essentially your slope. So your slope is the thing that makes the output vary, but your slope is going to be constant because it's a linear relationship. There's three different ways that we can kind of represent a direct variation. The first is with a table. So what to keep in mind about with a table is that the x and y are proportional. So let's look at a table example. Maybe I've got the coordinate 1 and 3, and then if I know the next one is 2, the output would have to be 6 if I want to keep it proportional. I could go one more, 3 to 9. So we're noticing for each additional x, the y is going up by 3. That means that our constant of variation is 3. What if I asked you on a table to go out to, let's say you're trying to find when x is 15, what would be that y value? Okay. This is where the idea of proportions are helpful. You know that how any pair of x and y relate to each other will help you to match up this. Sorry, the lights turned off. Okay, so our ratio of x to y from our first ordered pair, and really we could use any x to y pairing, will equal our 15, which is the x that we're given, to this unknown y coordinate. Okay, so we set up a proportion to help us find y. To solve a proportion, you're probably familiar with cross multiplying. So we'll take 1 times y to get y, and then 3 times 15 to get 45. So this missing value would be 45. The next way that you can represent a direct variation is with a graph. So if you're representing a graph, the thing to keep in mind with direct variation is that it always passes through the origin. So this is just a rough sketch. But if we were to plot the ordered pairs from our table, we have 1, 3, 2, 6, 3, 9, and so forth. So it's going to be, oops, kind of missed that one, a pretty steep line, but it will always pass through the origin if it really is a direct variation. Okay, lastly, the equation. The equation of direct variation is always in the form of y equals kx, okay, where k is this constant of variation. Okay. Our constant of variation in this case is 3, so we can write the equation y equals 3x to represent this relation. Nope, that's not an x. Kidding. Y equals 3x. So we can always say that if you take whatever the x value is and multiply it by 3, it will find you that output or that proportion. So that could have worked here as well, that instead of setting up a proportion, we could have written an equation by finding the constant of variation. And then from there, saying our x is 15, if we multiply it by 3, that should produce that missing y value, which is 45. Okay, that is it for tonight. We'll see you tomorrow.